Greetings everyone, my name is Isaiah Haggai Joseph, and the project circuit that I have in mind is coined as the Discrete Seat Mechanism. I'm pretty sure this idea is very relatable for our current situation. So firstly, to understand the application of this idea, we have to describe the problem. To conceptualize the applicability of this project, we have to envisage the chosen setting, a cyber cafe, where A, B and C, as shown, refers to the three seats arranged adjacent to each other in the cyber cafe. In this pandemic situation, how do we force customers to sit within the standard operating procedure where they must be at least a seat away from each other? For the following diagram, illustrates the few examples of the allowed arrangements of seating as well as the prohibited ones, where as clearly stated in the diagram, X indicates that someone is sitting there, while O indicates that the seat is empty, where the first two arrangements are allowed because the person is isolated by at least one seat, and the third one is prohibited because there is no social distancing between the people. Therefore, a logic system is planned where, if the customers do not obey social distancing, the whole row, collectively of the three tables, will shut down its power. This is indicated by the output Y, where output 1 will allow the whole row to switch on, and output 0 to switch off the whole row's power. This is controlled by the inputs indicated by A, B, and C in the order of seating. By adhering to this comprehension, a logic system was planned with 3 seats with 8 different possible combinations. The system is not limited to only a cyber cafe setting. It can also be imposed to other social settings that require social distancing. And next, the components that are involved are as shown.
So first, we want to look at all the 8 possible combinations for this combinatory logic gate, where the input will be 0, 0, 0, where by understanding this, the upper part here is connected to ground, whereas the lower part here is connected to the voltage input. So it's 0, 0, 0, which implies that no one is sitting at the table. The voltage output is equivalent to logic 1, which means that the whole row will switch on the computers. So for combination 001, where someone is sitting on the right side alone, the logic is also 1. For combination 010, which implies that someone is sitting alone in the middle, the output Y, which is expected, is 1 at high state, which means the whole row will switch on. Okay, so for the third combination of 011, which implies that the middle and the right seat is occupied, the logic Y is equals to 0. It's because they are sitting too close to each other. At combination 100, which means that the left seat is occupied, the total output Y equals to 1. And at combination 101, which means that the middle seat is left empty, logic Y equals to 1. For the second last combination of 110, which means that the right seat is left unoccupied, while there are two people sitting close to each other on the left hand side, logic Y is equals to 0. And now for the last combination, which is 111, where all 3 seats are occupied with no gaps in between the people sitting among themselves. This is quite obvious. Also, you guys can accurately predict the outcome, which is Y is equals to 0.
What happens when the circuit is not connected? When this happens, a phenomenon called floating will occur, where the input is not associated to either a high state or low state range, as shown in the diagram labeled with the yellow star. This indeterminate input in voltage will subsequently cause the output voltage to be vague, where the output will oscillate between high and low state. This is undesirable as we want our outcome to be as objective as possible. Among the problems that I faced during this project, number 1, some LED burned out because during the testing period, I did not apply a resistor to the circuit. Number 2, I accidentally bought a mini breadboard which caused insufficient space. which is why I could not insert switches to apply the input conveniently. And the third one is malfunction IC because of excessive input voltage. This was resolved by changing my initial 9V cell to two 1.5V cell. That is all for me. I hope my idea sounds reasonable. Merci beaucoup et au revoir.